Hey guys, and welcome back. This is the last section of the whole course, classification with K nearest neighbours. So in this section, we're going to be looking at what is a KNN, and when do we choose it, and then we're going to be doing the standard implementation example, and then finally we'll move on to a brief discussion about the limitations and strengths of a KNN. So this is video 5.1, when to choose a KNN. And in this video we'll look at what it is and when to choose it as expected. So what is a KNN? Well, basically K nearest neighbours is a type of classification algorithm. So it's supervised and it basically classifies an input based on the K training points which are closest to it. So this is really quite easy to get your head around. So if you imagine we've got some 2D data like this, let's think of an example. So we could have, not sure, but the number of people who use their left hand, a number of people who use their right hand or something. Actually, that's a terrible example. So let's just make it some arbitrary data. And you can see we've clearly got a cluster around here and a cluster around here. So basically what you do is in the training, you basically just embed this data in this space. So when I say space, I mean this 2D plane. That's the training done. And then all we do is when we have a point we want to classify, we find its coordinates, and its coordinates are the data features. So, whatever data it is, whether it's height, width, etc. And then you you go through all of the points and you find the ones that are closest to this point, the point we're trying to classify. So we find the K nearest points, and then out of those K nearest points, we find the majority of classes, which basically the modal class in the closest point, and then we assign it to it. So if you think about it here, we've got the three closest points are these two, and this one, so there's two more red than there are blue, so we probably classify this as this point. And then that's it, it's really simple. So the distance is in the standard Euclidean way. So you imagine, we've got our point here, and we want to get this point here. So you just compute the distance in X, and the distance in Y, and then it's just Pythagoras. So really easy to compute. Very simple, very intuitive, and there's not really kind of much more I need to say about how it works. Yeah, so each point you just find the K nearest neighbours in this space, and then you classify it accordingly. I will say that the data does need to be normalized, so you need to have the correct scales on each dimension or each axis. Otherwise it won't work properly. You'll just end up performing it in a line with the greatest dimension. So that was an introduction to choose a KNN.